Welcome to Thuma Mina Teaching. You are tuned in to Natural Sciences Grade 9. This is your fourth lesson for the second term. In today's lesson, we will be discussing acids and base as well as pH value. The key concept for today is pH. pH is the measurement used to determine the alkalinity or the acidity of a substance. It is useful to have a working knowledge on acids and bases as they impact our daily lives. For instance, our stomach secretes an acid that helps with the digestion process when we ingest food. The stomach acid contains a very strong acid called hydrochloric acid. When our stomach secretes too much acid, or when a lady is pregnant, they often suffer from acid reflux. To counteract or relieve the symptoms that present with acid reflux, we make use of medicine that has an alkaline base, as this neutralizes the acidic properties of our acid reflux. An example of this medicine would be Gaviscon, Eno, or Reni. In the previous lesson, we learned about acid rain. Acid rain lowers the pH of soil, which creates unhealthy circumstances for plants to grow and flourish. To counteract this, we add substances that are basic in nature to then again increase the pH of the soil to make optimal conditions for plants to flourish. Much like our stomach acid, vinegar and lemon juice are also acids, but they do not burn our throats when we swallow them, and therefore they are not as strong. We often add lemon or lime juice to freshly cut vegetables or fruits to prevent them from turning brown. This prevents oxygen from reacting with the fruit or the vegetable, which oxidizes the vegetable, turning them brown. So this is the perfect time to recap what we've done on acids and bases up to this point. Let's test whether you've mastered the content by solving the following questions. What is the scale used to determine the alkalinity or acidity of a substance? The scale that we use to determine whether a substance is a base or an acid is pH. And remember, a pH scale ranges from 1 to 14, with 7 being neutral. Below 7, you will find that substances are acids, and above 7, they are alkaline in nature. What is the acid in our stomach called that we use to digest our food? It is a very strong acid and it is known as hydrochloric acid. Why do we make use of medicine that has an alkaline base when we have heartburn? Heartburn is caused by having too much acid in the stomach. And how would we neutralize this acid? By adding a medicine that has an alkaline property to neutralize the effects of the acid. Do you think you will be able to classify whether the following substances are acids or bases? For our first example, we have Gaviscon. Now think of Gaviscon's use. Why do we consume Gaviscon? You're right, it's because it's a base and it can neutralize the effects of heartburn. Vinegar? Vinegar is a very weak acid. We know this because it tastes salty or sour. Our final example is sunlight liquid. And we know this is a base because it feels slippery and soapy. And have you tasted sunlight liquid? It tastes a little bit bitter. How does adding lemon juice to a freshly cut avocado pear prevent it from turning brown? Lemon juice prevents oxygen from reacting with avocado, and thus oxidation is prevented. Common household cleaning products usually contain a base. Handy Andy contains ammonia, which is a very strong base. The soaps we use in our house, such as the Dove we use to shower or the dishwashing liquid we use to wash our dishes, are also basic. That means they feel slippery to the touch and taste bitter. These soaps or bases are not as strong as ammonia and thus does not give off a potent smell. From this we can deduce that acids as well as bases can be very strong or very weak. The strength of an acid or a base is determined by using its pH. The pH of a substance is an indication of the concentration of hydrogen ions in a solution. The pH scale measures things from 1 to 14. When a substance is considered to be acidic, it has a pH of below 7. When a substance has a pH of above 7, it's considered to be a base. Neutral substances have a pH of 7. But what is an acid really? We know that it has a pH below 7, it tastes sour, and it feels rough to the touch. The chemical formula is also an indication whether a substance would be an acid, as acids usually have a hydrogen element in the beginning of their formula. But what is an acid really? Acids are chemical compounds that react with other substances such as metal. They are corrosive, that means they eat away at the metal, breaking them down and weakening it. The most common acids we use in the laboratory is hydrochloric acid and sulfuric acid. In contrast to this, we have bases. They have a caustic action on plant and animal material. A substance is caustic when it burns the material or the skin. The pH of bases range from above 7 to 14. The higher the number, the stronger the base. Compared to acids, bases taste bitter and they feel smooth, soapy or slippery. Much like acids, we can also determine whether a substance is a base when looking at the chemical formula. Bases tend to have a hydroxyl group at the end of the chemical formula. Examples of this is potassium hydroxide or sodium hydroxide. Although we've mentioned how both acids and bases taste and feel, I should warn you that you should not ingest or touch any substances that you are not sure of, as they can have damaging effects on your body. So given the theory that we've just gone through, when we consider washing our hair, we often grab the shampoo. It feels slippery and soapy to the touch, and when it enters our mouth, we taste a bitter taste. And when the worst happens, it goes into our eyes, they start burning. That is the caustic action the base inside of your shampoo has on your eyes. On the other hand, tomato sauce and fruit juices often taste sour. They are a little bit rough, making them acidic in nature. Neutral substances show no acidic or basic properties. The pH value of a neutral substance is 7. An example of a neutral substance is filtered water. One would be inclined to think that tap water is also a neutral substance, but it is often cleaned with chemicals that contain either chlorine or ammonium. The chlorine would result in the water becoming a little acidic, and the ammonium would result in it becoming a little more basic. So when we taste water and we touch water, this neutral substance, what do we taste and what do we feel? Neutral substances taste like nothing, and they simply feel wet. Let's consolidate what we've just covered by answering the following questions. What is an indication of the concentration of hydrogen ions in a solution? The answer is the pH. Now you'll remember hydrogen ions indicates whether something is an acid or a base. The higher the concentration of my hydrogen ions, the more acidic my solution is. We will have a number on the lower end of the scale, a 1 to 6 perhaps. So which substances have a pH of more than 7? These will be called bases. What pH does pure water have, and why do you think so? Water is a neutral substance and therefore it will have a pH of 7. By looking at the chemical formula of the following compounds, can you identify whether they are bases or acids? Our first example is HCl. HCl represents hydrochloric acid, and as the name gives it away, it is considered an acid. Our second example is H2SO4. This represents sulfuric acid. It is our second strongest acid that we are aware of in the laboratory. NH4 represents ammonium. Ammonium is a base. KOH is potassium hydroxide, and it is considered a base due to the OH group or the hydroxyl group at the end. CaOH, calcium hydroxide, and again there is a OH group present at the end, so it is a base. Let us compare or highlight the differences between acids and bases. For this question, we will first discuss pH, then taste, and finally touch. With regards to pH, acids have a pH below 7. And bases have a pH of more than 7. When comparing taste, acids tend to taste sour or salty, whereas bases taste bitter. And finally, touch. Acids feel rough on the hands, whereas bases, they tend to feel more slippery or soapy. When we are asked to compare or highlight the differences between two things, we must discuss a factor for each of the substances at a time. So in this question, we started by comparing the pH of both an acid and a base. One does not compare the pH of an acid to the touch of a base. We must consider one single factor and only discuss that single factor. So I will always compare the taste of an acid to the taste of a base. Also, always look at the mark allocation for your question, as this gives us a hint as to how many factors we are asked to compare. What are the most common acids that we use in the laboratory? The most common acids found in a laboratory is hydrochloric acid and sulfuric acid. Both are very strong in nature, and therefore we always tend to use them in the diluted form. What does it mean when we say that bases are caustic in nature? This means that a substance is strong enough to result in a chemical burn on the skin of an animal or a plant. It is therefore harmful to the body. Again, I would like to stress that you should not taste or touch any unknown substances in a laboratory, as they can have harmful effects on your body. So if you're not allowed to touch and taste substances in the lab, how would we determine if something is acidic? We make use of indicators to determine whether a substance is a base, acidic, or neutral. These indicators are chemicals that change color in the presence of a base, an acid, or a neutral substance. Some indicators are commercially available, such as the universal indicator, that not only tells us whether a substance is acidic or basic, but also the exact pH of the substance. Naturally occurring indicators, although not as accurate as chemical indicators, can also give us information regarding the acidity or the alkalinity of substances. We can make natural indicators by using turmeric, red cabbage leaves, or beetroot. The chemical indicators that are sold commercially include bromothymol blue, the universal indicator, and litmus paper. So when we do these experiments, it's good to know what the color change would be. Otherwise, it's just useless information. When we use a natural indicator such as red cabbage water, it should turn red or pink in the presence of an acid. Red cabbage water is generally purple in a neutral substance, and it becomes green or yellow when I add a base. This indicator, like many others, can be prepared by boiling the red cabbage leaves in water. Once the solution has cooled down, you test substances by adding it to the water. Bromothymol blue is a very common laboratory indicator. It appears yellow in the presence of an acid, green in the presence of a neutral substance, and when a base is introduced to the solution, it turns blue. The most accurate indicator that we have is the universal indicator. Universal indicators appear to be yellow, orange, or red in the presence of an acid, depending on the acidity of that substance. Universal indicators become green in the presence of a neutral substance, and they appear blue or purple in a base. If the base is very strong, the hue of the purple will be much darker. What makes this indicator so amazing is the fact that it not only tells us whether a substance is a base or an acid, but also accurately indicates the correct pH of the substance. Remember that pH ranges from 1 to 14. The universal indicator is made up of compounds that uniquely react with a substance. Once the reaction is complete, it undergoes a color change, thereby giving me red, blue, or green to indicate whether I'm busy with a base or an acid. But the shade of the red, blue, or green, or yellow indicates the specific pH of the substance. Can you tell me what is a chemical indicator? A chemical indicator provides us with information regarding a substance alkalinity or acidity by means of a color change. Some indicators are able to tell us the exact pH of a substance. Can you remember what color change can be observed when adding an acid to purple cabbage water? In questions like this, we must always state the nature or the color of the substance before the change was observed, and you must only write down what you actually saw happen. In our example, the cabbage water was purple. When adding an acid to purple cabbage water, we will observe a change from purple to red or pink depending on the strength of the acid added. What color change can be observed when adding bromothymol blue to clear water? The color change observed, clear water will turn green. Can you remember which industrial indicator is considered to be the most accurate and why? The universal indicator is considered to be the most accurate. Not only does it tell us whether a substance is an acid or a base, but it is also able to tell us the exact pH of the substance. Let's head over to High School Stellenbosch, where Ms. Lamprecht will be conducting the lab experiments that accompany this lesson.
In this reaction, we will be examining the difference between an acid and a base. By now, you should know that an acid has a sour taste and it can burn your skin when you have an open wound. Good examples of acids include acids we use in the laboratory, such as hydrochloric acid, as well as substances we find in our everyday use, such as tea or coffee or even fruit juice, are all examples of an acid. Examples of bases are household cleaning supplies. Bases have a bitter taste and they can also be very harmful when a concentrated base comes in contact with your skin. The substances that we're going to examine today are vinegar, lemon juice, sodium bicarbonate, and water. I have two indicators that we are going to use to determine whether these substances are an acid or a base. The first indicator is bromothymol blue, and the second is universal indicator. Bromothymol blue is a very good indicator to indicate if we have an acid or a base, as it will change to green when the substance is neutral, yellow when it is an acid, or blue when it is a base. Universal indicator is a more accurate way to test for an acid or a base, as it has a wider variety of colors it can change to. The darker the color, the stronger the acid or base. The lighter the color, the weaker the acid or base. For our first experiment, we will examine vinegar. The vinegar changes yellow when the bromothymol blue is added, indicating that vinegar is an example of an acid. When the universal indicator is added, it changes orange. Orange indicates that this is a strong acid. A strong acid will have a pH of between 0 and 3 on the pH scale. Next, we will examine the lemon juice. Lemon juice is a bit harder to see the color change as it isn't a clear substance, so you need to look carefully. The bromothymol blue changes the color to a deeper yellow, indicating that lemon juice is also an example of an acid. The lemon juice changes orange when the universal indicator is added, indicating that it is also a strong acid with a pH between 0 and 3, another strong acid. Our third substance is sodium bicarbonate. The bromothymol blue changes blue. This is an indication that this is a base. The universal indicator will tell us how strong this base is. It changes the dark blue, indicating that this is also a rather strong base. A strong base has a pH between 11 and 14 on the pH scale. Our last substance is water. When the bromothymol blue is added to the water and it is mixed, it changes green. Green is an indication of a substance with a pH of 7, also known as a neutral substance. The universal indicator also changes green. Water has a pH of 7, making it a neutral substance.
Thanks, Ms. Lambrecht. That was very insightful. Now let's see if you have the knowledge to answer the following questions. This marks the end of lesson 4. See you next time when we will be discussing the reaction between acids and bases part 1.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.